Alright, I'm being asked to write an equation for this table. Now, you may start out deciding, I'll just find the slope. So let's see here, 8 to 16, I'm adding 8. 16 to 32, I'm adding 16. And 32 to 64, I'm adding 32. So you can see the slope of this is not constant. Since the slope is not constant, I can't write just like a linear equation by finding the slope and the y-intercept because it's not linear. I'm going to have to use a different form of equation because this is not a linear equation. I know it's not linear because the slope is not constant. So maybe I can look at this pattern a little bit differently. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. And since I'm multiplying by the same thing, this must be an exponential relationship. And this number I'm multiplying by, that's called the growth factor. And to write an exponential equation, the format is y equals the y-intercept times the growth factor to the power of x. I got that x from here. That's my independent variable. So that's what goes here. I've got these two blanks I got to fill in. So that will be my y-intercept. And inside this parentheses is my growth factor, which I know that. I'm timesing by 2, so a 2 goes here. That's my growth factor. Now the y-intercept, it's similar. I find it in the same way I would find it for a linear equation. I go back to when x is 0 and figure out what had to be before that. And so I ask myself, okay, what could I multiply by 2 to get 8? And the answer is 4. 4 times 2 is 8. So I need to put a 4 here. So the equation is y equals 4 times 2 to the power of x. I'm using this parentheses to show multiplication. If you wanted to, you could write y equals 4 times 2 to the power of x. And these are equivalent. Both of these equations mean the exact same thing. They're both correct. They just usually use this parentheses when they are writing an exponential equation. Don't know why. That's just something they do, but they're both right. It doesn't really matter.